Okay, 7th graders, about halfway through chapter 10. Today we're looking at multiplying monomials, which is a fun new word. Having your vocabulary out would be a great choice for this section. You can add a couple new things. For this lesson, we are on lesson 10.5, and that is page 545 in your textbook. To do this lesson successfully and make it all make sense, we're going to review a little bit of our prior knowledge. We've used the word power before, but do we really know what a power is? If I showed you the value of 5 to the third power, I call this entire thing a power. This is what a power is. A power is made up of, though, a base and an exponent. So we really need to review, what do these things in the power, the base, the exponent, what do they tell us about the value? What the exponent tells us is how many times to multiply our base by itself. So this really is the same as 5 times 5 times 5. I could also say, if I just combine these two, I know this is the same as 5 to the second times another 5. A number times it really just by itself there is 5 to the first. But I did just decide that all this together is 5 to the third, like we saw above. So this is kind of a really quick introduction to what we're going to look at today. So powers, we know, are made up of bases and exponents that we can use to write together. Okay? So with our vocab, we are looking at monomial. I think it's kind of a fun word and a little tricky to say sometimes. So we have a monomial is a number, a variable, or a product of a number and one or more variables. Excuse me, I have a little bit of a cold still. So a couple things in there that we need to know. A number, we know our numbers like digits 0 through 9. Okay, and obviously above the tens, place, hundreds. Any number. A variable we know is a letter in place of a number, something that we don't know or that we're looking to find. We also need to remember that a product, what is product? That is an answer to a multiplication problem. So we know that a product is found by multiplying numbers. So I would say the product of 2 and 6 is 12. So 12 is a product because it's the answer to a multiplication problem. So a monomial is just a number, a variable, or a product of the two. Okay, so looking down here, we see that this is a product of a number and an exponent there. So that's a power, a product of these two powers. We know that 3 to the second is the same as 3 times 3. We're multiplying that 3 times 3 times 3 to the fourth, which is really 3 times itself 4 times. Like we notice here, so this is our 3 to the second, this is our 3 to the fourth. That is really the same as those 6 3's multiplied by themselves. So we can write it as 3 to the sixth. So kind of like we talked about in our Get Ready for Chapter 10 way back a couple days ago, we are kind of combining our like terms, which is 3 is the same number, and putting it to an exponent to tell us how many times we want to multiply that number by itself. So we're looking for, what do we notice here? And this is in our book, of course, on page 545. The product of powers. Again, product we know is multiplication, and powers are a base with an exponent. So what this means, to multiply powers with the same base, you're just going to add the exponents together. So if I wanted to multiply 2 to the fourth times 2 to the third, I really just multiply those exponents of 4 and 3 together and end up with 2 to the seventh. And I can see that that is true because if I have 2 to the fourth, I know that's the same as 2 times 2 times 2 times 2. I multiply those 4 2's by 3 2's, 2 to the third. So 2 times 2 times 2. So I just multiplied these two terms together. And what I notice is that I end up with 1, 2, 3, 4, 5, 6, 7 2's. I'm multiplying 2 by itself 7 times. So all I really did was add those two exponents together. It's a pretty nice and quick trick. It's really basic today. It looks a little complicated, but it's really just like adding, okay? Because multiplication really just is repeated addition. So let's take note of that. All right, so another example. If we're going to try to find 5 to the second power times 5, we're going to want to express this using exponents. So we might want to write this out. Well, 5 to the second is really 5 times 5, and then times another 5 is times 5. So I do realize that this is 5 to the third. But if they want us to express this using exponents, I'm going to say, okay, this 5 to the second, and this is really times 5 to the first power. And I know from my rule above that all I'm really doing is when I'm multiplying powers together, kind of looks like a smiley face there. When I'm multiplying those powers together, all I really do is add those two exponents together for a value of 5 to the third, just like I saw right away. Okay, so this is really helpful. This example is really helpful. Say those exponents were a lot larger, and we won't want to write 5 out 10, 20 times. So this makes it really nice for us when we're looking for the product, the multiplication of powers. This next one's pretty fun, I think. What you need to do on these, it looks a little bit complicated, is like we've done before with our combining like terms. Kind of find, you're going to take out your coefficients, our -3 and our 4, and we're going to multiply those together separately, and then multiply our like values of our x's. We're going to multiply those together as well. So it's going to look like that, okay? Make sure you're taking notes with me. It's going to be super helpful for you when you get to class tomorrow. So here we know -3 times 4 is a -12. What we also know is when we multiply powers together, that's really just us like adding our exponents. So this is x to the second plus the fifth. Okay, so this isn't too bad for us. So now I can simplify that. Well, it's a -12 coefficient times x. 2 plus 5 then is just 7. Okay? So knowing that, why don't you pause your video quick and try this next one, and then when you come back, we'll be able to do that one together. So, just like the other example, which I'll use as a guide, I'll use my book as a guide, I'm going to take my coefficients of -2 and -8, and I'm going to multiply those together. I'm also going to multiply this by my m to the first power, because there's nothing there, it's to the first, times m to the fifth. I'm going to simplify these down a little bit by doing my multiplication of -2 times -8. A negative times a negative I know is a positive 16. And this is times m, adding my exponents of the first and the fifth. So here I am. I'm going to finally simplify that for 16 times m to the sixth power. This isn't so bad. I kind of like this stuff. It's like finding the things that go together and putting them all in one piece until it's down and simplified to one nice piece instead of multiple. Okay? What I have on this example, which again is in my book, I have this here, and it's on example 4 in my book. What I notice is that I have a negative exponent. And if we think back to lesson 2-9 or even our get ready for chapter 10, I remember that a negative exponent has to be flipped to be its multiplicative inverse, or Miss Simmer's favorite word, reciprocal. So I know this is really the same as x to the fourth times 1 over x to the second. Okay? And that is going to be something we also look at when we get into division next week. So another way you can look at it this way, or we can look at it by going, okay, this is the same as x to the fourth plus x to the negative second. You just add those exponents together. Luckily here, we end up with the value of x to the fourth plus negative 2. 4 plus negative 2 we know is a positive 2. So you end up with it that way. Since this one's a little bit more abstract, I'm going to show you a picture of how this looks if you think about it this way. If we're looking at, we really have 4 x's multiplied by each other on the top and 2 multiplied by each other on the bottom. All we know about a number divided by itself is that it just gets to 1. Any number times 1 is just the number you started with. So what I can really look at is these kind of cancel out, and all I am left with is x times x. So that really does kind of check my answer and tell me that I am right, that that is x to the second power. So here we are with one more just regular multiplying the products of powers together here. So I'm going to multiply my m to the negative 1 times my m to the negative third. Just like my rule, I know that when I'm multiplying powers, I really just add my exponents together. So I have a negative 1 plus a negative 3. I do know that that simplifies. Obviously, negative 1 plus a negative 3 is a negative 4. I know from my other experience from lesson 2.9 and my chapter 10 Get Ready that I'm not going to leave this as m to the negative fourth. I know that this is going to make it my multiplicative inverse, and I'm really going to flip this around to be 1 over m to the positive fourth. So that is going to be my simplified answer for m to the negative fourth. Okay, so make sure, go back if you need to, check any notes on those things, use your resources, and get ready to ask some questions tomorrow. So lastly, you're going to see some word problems coming up with these concepts. So let's think about how we'd go about this. The Guadalupe River is 2 to the 8th miles long. The Amazon River is 2 to the 4th times as long as, so meaning as long would be as long as the other river. So we're going to find the length of the Amazon River. So I'm going to give you a minute to kind of check out how are you going to set this one up. So think about that for a minute. Okay, well, just like we've been talking about, as long, you're going to be multiplying these two values. So you have 2/8 is the value of the Guadalupe River, okay, times the Amazon is 2 to the 4th power as long as that. So the Amazon River is really this long in addition to this much long. So what you have to do is multiply those together, which we know is just like adding our exponents. So 2 to the 8th plus 4. So we're given a value of 2 to the 12th. Say I'm looking at this word problem, so I'm probably wanting to actually solve and find out, and this is in miles. So I would do on my calculator, I might type in, or on paper, you would just list 2 times 2 times 2, 12 times. Or I can take on my calculator, it's going to look like 2 and that little, that kind of caret button to the 12th power. And you're going to end up with a value of 4,096. And obviously, since this is a word problem, I'm going to label it with my miles. So what this tells me is that the Amazon River is 4,096 miles long. And that is longer than what the Guadalupe River is. So we could find out definitely what the Guadalupe River is by putting this into our calculators as well. So using your words and using your knowledge of what these concepts are, you can definitely go and solve some word problems successfully when you get to class tomorrow. Make sure you're coming with questions and a smile. See you then.